Welcome to ClickMyProject.com.
Now we discuss about a comparative study of power supply architectures in wireless electrical vehicle charging system. In the developing world, there are alternative sources for the normal organic fuels. Here we use the electrical vehicle for the future travel techniques. The electrical vehicle, there is the problem will be the charging. Here we use the electrical charging by using the normal portable cables and the frequency. In our process, we design the inverter from grid AC to DC for using the charging the electrical vehicle. In this process, we use the wireless charging system for charging the vehicle. It is help to charging the vehicles during movement of the vehicle and also the parking time of the vehicle. Here, there is no need any external weapons are not needed to charging the electrical vehicle's batteries. Here, the topology is basically normal LLC inverter will be used. In this process, the inverter will be connected between the source to load by the air medium. Here, the mutual induction will be used to induct the primary coil current to secondary coil load. Here, the feedback signal will be getting from the wireless sensor networks. That is help to improve the future vehicle charging system. Now we see the flow diagram for our proposed work. In this flow diagram, first we get the input from the grid. And the grid is the 3-base AC and it is converted to the DC current and it will send to the inverter. And also it will be sent to the mutual induction and it will be go to the battery for charging system. Here the inverter controlled by the PWM. The PWM controlled by the output signals from the converters from the wireless network in the real-time process, and it will be change the inverter voltages based on our output voltage level. Here the mutual induction will help to transfer the current from primary side to secondary side, and also it is used to buck or boost the output current and voltage. The power balance is maintained by the control signal getting from load to PWM. Now we are going to see the demo of our process. Run the main.num and the window will be open. Here the monitor system for car and it is the source monitor. If you want to see the model, press the model button for see the model and press the scope. We see the scope for getting the output voltage. Now click the auto for the control for autos. Here the car will be moving and it is the our source current and it is our car. Now the nearest charging source is 0 meter. Now if you aspect, are you sure the battery will be charging? Now you use the aspect for charging the battery. Now the simulation will be start at 10 seconds. Now here the time second for balance the output voltage from getting from the source. Now the voltage will be balanced from source to car to source. Here it is the source voltage of 185.68 and the voltage of 194.21. Now the voltage will be getting the 190 volt. Automatically the car will be charging. Here that car will be charging. The car charging percentage will be shown here. Now it is the power versus efficiency curve. After 100% charging, the simulation will be automatically stopped because the source will be stop the current, and it is a time for maintain. It is time for maintaining the output voltage for battery charging from the getting from the grid. It is a settling. It is like settling time. Now, if you want to see the model, click the model. It is open the or simulink model. The simulink model, the input AC grid will be there, and it is be converted to the DC current by use of the rectifier, and then the grid voltage will be sent through the inverter, the full bridge inverter. The full bridge inverter controlled by the pulses, and then it will be go to the transformer. The transformer is like a mutual induction. This mutual induction, the core will be the air medium, and that will be sent through the mutual induction, and it will be converted to the another inverter. That inverter will be convert the AC to DC, and then it is connected to the load. The load will be the battery charging system. And here, in between the mutual induction and the primary side, the transformer will be used. The transformer will be boost the input voltage for maintaining the losses during the mutual induction time. And that before the DC conversion, the rectifier will be used to convert the AC to DC formation. Now we get the power and voltage analysis from the here. Now, if you want to see the scope, it is the grid voltage, it is the input voltage, and it is the input current, and it is the inverter voltage, and it is the inverter current based on the time. It is the transformer voltage, it is the vehicle input voltage, it is the vehicle battery voltage from DC, and it is the vehicle battery current, and it is the input power, and it is the output power, and it is the efficiency.